Hey guys, in this lecture we're going to go over functions. So let's consider a simple task. Let's just add two numbers together. It's equal to 2 plus 3. Actually, let's do it like this. And a is equal to 2 and b is equal to 3. And then we're just going to do a plus b. Okay. And then we can print out that sum. Okay, so it's pretty straightforward. We've been doing this for quite some time now. It's just going to print out 5. Let's, instead of doing it like that, let's create something called a function or a method. I'll explain exactly what this does just after I type it. Looks like int add a b, and then return sum. Okay, so what is this? Well, in this function, for the first thing we need to do is ignore these first two words, public and static. In fact, we can actually get rid of the public. The static we need right now, but it's kind of difficult to explain why we need it until we've actually gone through object-oriented programming. So just ignore why we need the static and just say that you need to have it when you're working inside of your main class. Then just look at this part right here. So what this is doing is it's creating something called a function. So in math, for example, if you've ever taken algebra or maybe like geometry, you know that you can have functions that take in a number, like f of x. So you take in some x value, and then you spit out some value f of x. And that gives you something that you can plot on a graph. So you can have many different values of x, and then each of those values of x gives you some value of f. So similarly, what we're doing here is we're declaring a function that takes in two values. It takes in a value called a, and it takes in a value called b. Now, inside the function, what we're doing is we're adding a and b. We're adding a and b. So we take the value of a, we take the value of b, we add them together, we store the result in sum, and then we spit out sum. So we return sum, basically. So when we have f of x, we take in x, and then we spit out some value f of x. Okay, cool. So in this case, we can see that if we were to add these two numbers using our old way, we would get a value 5. Now, we can get the same result. Int add 2 is equal to add a, b. Then we can print out add 2, and we'll also get 5. Okay, so note one thing here. Even though we say that we want the first parameter to be called a and the second parameter to be called b, that doesn't mean that the variables that we pass in have to have the same name as these parameters. So these are what we call parameters right here. These are parameters. They're the stuff that we pass into the function. The input values, the stuff we're putting in, they're over here. We can call them anything we like. We can call this x, we can call this y. Let's get rid of this add right here. Let me just change it. X plus y. We can call them anything. X, y. And we can print it out and we'll get the same result. If you want maybe like an intuitive explanation for why this is, I mean, again, think of math. You can have a function called f of t, but you can provide any value of t. You can even provide value of x's. It just has to be some kind of number or decimal. It really doesn't matter. So the stuff that you put in, its name doesn't have to match with the names of your parameters. Okay, so that was cool, but let's create a function that's a little more interesting. Suppose that we wanted to calculate suppose that we just wanted to see if a number was prime. Is number prime int a? Okay, so how do we check if a number is prime? Well, the first thing we need to do is we need to consider what a prime number is. So a prime number is a number that is divisible by itself and 1, but isn't divisible by any other number. So 7 is a prime number. 7 is divisible by 7 and 1, but it isn't divisible by 2 or 3 or 4 or 5. So 7 is prime. Another prime number is 13, then we have 17, then 19, 23, and so on and so forth. So we have these prime numbers, and we want to see whether a given number, a given value called a, is prime. So how would we do that? Well, okay, so let's look at how did we know in our heads that 7 was prime? Well, what we did was what we could do actually is, well, we could do 7 divided by 1, and we see that that gives us a remainder 0. But we don't really care about 1 because that's the condition for being a prime number, basically, or it doesn't help us in looking to see if a number is actually prime. What we want to do is we want to divide by numbers like 2 or 3 and 4. So 7 divided by 2, it's a remainder. We can denote the remainder by the modulus operator. So remainder 1. Then we can do 7 mod 3, and we get a remainder 1. Remainder is 1. What about 7 mod 4? Well, 7 mod 4 is, let's see here, that's going to be remainder 3, remainder is 3, and so on and so forth. And what we find is that the only time the remainder is 0 is when we do 7 mod 7, that gives us 0, and 7 mod 1, that gives us 0. So let's look at a number that isn't prime. So for example, 8. So 8 mod 2 is equal to 0, and if we know that the mod 2 is equal to 0, or sorry, if we know that our number modulo any number other than itself and 1, if that modulo equals 0, then the number must be prime, because you can divide it by a number other than 1 or itself, such that you get remainder 0. 8 is not remainder 0 for a number other than 1. Okay, cool. So let's just create a very simple algorithm. And all we're going to do is we're going to loop until we hit, we're going to loop until we hit A. So I is going to start at 1 because, sorry, I is going to start at 2 because we don't really care about checking to see if a number is divisible by 1. We know that every number is divisible by 1. And we're going to go up until we hit A. Or actually, we can do it like this. We're going to return true by default. So let's just, when we return true by default without having actually defined our function, we're in essence saying that, you know what, we just think that if we reach this point right here, then we're going to say that the number is prime. That means that we have to have some kind of condition in here that returns false if a number isn't prime. So if A mod I is equal to 0, then return false. We're done. So let's just walk through what this does. So I starts at 2, and then we see if A modulo 2 is equal to 0. Well, if it is, then if the number is divisible by 2, then it's not a prime number, and so we return false. Then I goes up by 1, so now I is 3. If the number is divisible by 3, then we return false because the number isn't prime, and then so on and so forth until we go to 4, 5, 6, all the way until we hit the number A. Okay, cool. So now let's test this out. Boolean is prime is equal to is number prime, and let's just check 7 because we know that 7 is prime. Println is prime. So 7 prime, yes. Okay, let's check a non-prime number. Let's do 4 and false. Good. Okay. So this was a pretty simple check to see if a number is prime. There are more sophisticated algorithms, but you know, this is just an introduction to functions, and I hope you guys found this interesting. In the next few lectures, we're going to go over basically functions in a little more detail when we cover object-oriented programming. I'll see you guys then.